Today we are talking about belts and bearings. I will be sharing about belts. So, to start with, we have this wheel with a belt on it, and our impending motion is going this direction, so that means our force has to be going in the opposite direction. And so then I said force instead of friction.
Friction is going
I
the
meant
opposite direction.
friction
Yep.
is going the opposite direction, and so then our force is also going the opposite direction of friction, and that means that force is greater on T2 than it is on T1 because friction is resisting the impending motion. So, our equation, the U is the coefficient of static friction, and the fancy B is radians of contact, which means wherever this belt is making contact with this wheel is our fancy B thing, like that. And so our two situations that we use this is when we're solving tension from the belt, T1 or T2, or we need tension from the belt within a force balanced equation. And back to my radians part, since we are using radians, pi equals 180 degrees, and our radians equals revolutions, which is 360 degrees, divided by 2 pi. Did I get everything?
Yep. Okay. Next part of this we're talking about is bearings. There's 3 types of bearings: collar, pivot, or journal bearings. A collar bearing just means it has a little bit of collar sticking out kind of from the rest of the bearing, and that's what's causing friction with the rest of the motion or the rest of the surface around it. Pivot bearing just means it's a solid piece and it's having friction or kind of resistance on just this bottom piece. And then a journal bearing is just like bearing inside of a normal piece. That's how you usually think about a bearing. And there's 3 equations for each of these. For a collar bearing, you have that the moment is equal to 2/3 coefficient of static friction times the weight of the force down, that's P in this example. And then you have this kind of complicated equation, but it's just dealing with R2 and R1. R2 is the distance from the center to the outside of the general part of the bearing. R2 is the distance from the center to the outside of the collar of the bearing. So that difference helps you identify the little distance that's on the collar, and that's your kind of key point of contact. For pivot bearings, you have that the moment is 2/3 the coefficient of static friction times PR, and you have PR is just your radius, since that's a normal bearing this time, and that's a pretty straightforward equation. For a journal bearing, you have M equals PR times the sine of the angle of K. This one's a little bit more complicated for finding this angle of K, because if you think about the circle rotating in the middle, you have friction that's resisting it. This is kind of just a general chosen point, by the way. Friction is resisting it at that point. Normal force is perpendicular to it at that point. So you have a resultant of those 2 forces, and you get the angle of K because that's the angle between just your general resultant and your normal force. And that's what you'll end up using in here. Other way to find this is that your angle of K is the tangent inverse of your coefficient of kinetic friction, which would be when it is moving already. Otherwise, you just plug and go from the rest of these equations. Same thing for most of these. I think that's about it for bearings and belts.
Yep. Thank you. Have a great night.